Hello guys. In today's grade 12 Physical Sciences Momentum and Impulse Exam Clinic, we are looking at a question paper from KwaZulu-Natal. This is their Physics Paper 1 exam of September 2025. As you can see, this question was a 12 marks question, so it should be done in 12 minutes. Remember, for every mark, you should spend a minute. All right, for every mark, you should spend a minute. So let's get into it and see if we can finish in exactly or less than 12 minutes. All right, let's see. A boy of mass 60 kilograms on ice skates is stationary on a frictionless surface. He throws an object of mass 4 kilograms at 3 meters per second horizontally in the westerly direction as shown in the diagram below. You can see the diagram. They have also given you a cardinal point, sort of a compass, cardinal points, right? So they gave you a compass. Right, at the instant the object leaves the boy's hand, the boy starts moving. 4.1. In which direction does the boy move? Write down only east or west. He was stationary. He threw an object to the west. He will move to the east. And this is explained by Newton's third law of motion. Remember, you are in momentum and impulse. Do think of Newton's laws. Now, name and state the law which explains the direction in which the boy experiences a force when he throws the object. I said to you, the law is Newton's third law of motion. All right, it is Newton's third law of motion. All right, so what does it say? Newton's third law of motion says when object A exerts a force on object B simultaneously exerts an oppositely directed force of equal magnitude on object A. In other words, in simple terms, when object A exerts a force on object B will exert a force of equal magnitude but in opposite direction to object A. So let's write this law. So when object A exerts a force on object B simultaneously, object B, can I squeeze simultaneously here? Yeah. Object B simultaneously exerts an oppositely directed force on object A. An oppositely directed force on object A. Okay. So this is your Newton's third law of motion. Okay. This is your Newton's third law of motion. Now let's see, moving on. Calculate the speed of the boy immediately after the object leaves his hand. Remember, momentum calculations are vector calculations. So before you proceed, you must state a direction you want to be positive. I will choose eastwards being positive. Okay. I will choose eastwards being positive. So I will say east is positive. Okay. Now we use the law of conservation of linear momentum, right? Where we say mass of the boy multiplied by final velocity of the boy, then we use final first, plus mass of the object multiplied by final velocity of the object equals, initially the boy and the object were a unit. So open brackets, mass of the boy plus mass of the object, close brackets, multiplied by initial velocity. All right, cool. So the mass of the boy was 60 kilograms. The final velocity of the boy, we do not know it. The mass of the object was 4 kilograms. And then the final velocity of the object, they said it moved 3 kilometers per second in the west. So because we chose east to be positive, the west must be negative. Okay, cool. Once again, mass of the boy is 60, mass of the object is 4, and then the initial velocity of the two was 0. So let's see. 60 times final velocity of the boy minus 4 times 3 is 12, minus 12 equals anything divide anything multiplied by 0 is 0. So here we have 60 final velocity of the boy equals 12, right? So now final velocity of the boy is 12 over 60. 12 over 60 is the same as saying 1 over 5. So our answer is 0.20 meters per second. The question said we must calculate the speed. So as calculating the speed, we don't have to worry about the direction because it just wants the speed. Okay, perfect. Now 4.4, how will the answer to question 4.3 be affected if 4.4.1, the boy throws an object at a higher velocity in the same direction. Choose from increases, decreases, or remains the same. From the law of conservation of mechanical energy, we are basically saying mechanical energy of, let's say, the boy will be equal to the negative of mechanical energy of the object. Basically, this is what we are saying. So, however, no, this looks like I'm saying, let me fix this. Okay, so however, whatever change you need to make, you need to recall that change in momentum equals mass times change in velocity, right? Now, the question said the boy throws an object at a higher velocity. So if velocity of the boy, of the object rather, is higher, this will imply velocity of the boy will also be higher because there is a direct relationship between the two. Okay, so our answer for this particular question, our answer is increases. Okay, you recall, guys, momentum is equal to mass times velocity. Momentum is directly proportional to mass. Momentum is also directly proportional to velocity. So if mass increases, momentum increases. If velocity increases, momentum increases. Okay, cool. Now 4.4.2, you know what, for this thing, let me just give it colors to show that it is not your submission. This is me helping you get your answer right. All right, 4.4.2, the boy throws the mass of throws the object of double the mass at the same velocity. Choose from increases, decreases, or remains the same. Once again, we will say increases. Okay, because I just explained here. So it'll be increasing, right? If you increase the change in momentum of one, the change in momentum of the other will increase. Okay, so let's see. 4.4.3, explain your answer to 4.4.2. We will say when the mass is doubled, okay, when the mass is doubled, the change in momentum is doubled. Okay, the change in momentum is also doubled. Okay, the change in momentum is also doubled. Okay, the change in momentum is also doubled. Then you say momentum of the object. Let me just write the object, say object in full, is directly proportional to change in momentum rather of the boy. Okay, this is sufficient. When the mass is doubled, the change in momentum is also doubled, right? Then you say momentum of the object, change in momentum of the object is directly proportional to change in momentum of the boy. Therefore, change in momentum of the velocity, right? Velocity of the object, right? Or let me say change in velocity of the object will be directly proportional to change in velocity of the boy. Basically saying the same thing. Okay, and this is it. This is how you roll. So with that being said, it's a wrap and bye bye.